Stop my camera. Start presenting. Okay. Can you see my screen properly?
Yes, sir.
Okay, very good. I think we will continue with this wherever we left. Last class, I think we did few problems only. Problem 42. Okay. Some of the students who were regular in the last year, I think they have scored above, somewhere around 300 and something to 400. Some of them above 400, right? So as far as physics goes, I would say, I wouldn't say it was easy. At the same time, I wouldn't say it is very difficult, right? So at least 50 50 to 70% of the problems you could have attended it. People would have attended it, provided they had done the past year questions. If you have not done the past year questions, obviously, they will say it's very difficult. Maybe some 5 or 10 questions were very difficult. Others were like, from the past year questions only. So that's why I keep on saying, by doing the past year questions, one thing is you will understand the concepts. Another thing is you will get the working practice. So both are required. Okay, 42 we have done. 43, let's see. So 42 we finished, 43 we can check it out. Don't have enough space here. Maybe I should start. Forty-three. Okay, 100 Newton force acts horizontally on a block of 10 kg placed on a horizontal rough surface of coefficient friction mu. The acceleration due to gravity is taken as 10 meter per second square. The acceleration of the block is. So if I am pushing this way, the friction will act this way. So F friction is equal to mu into N. N is nothing but mg in this particular case because mg will be acting downwards, normal reaction will be acting upwards. Okay, only in the inclined plane n will not be equal to mg. So this is mu mg. Okay, the acceleration of the block. So acceleration means they're asking you what is the acceleration here. So very simple, sigma f, sigma f is equal to ma. So 100 Newton minus this one minus mu mg is equal to ma. So 100 minus 0.5 into kg, 10 kg, gravity 10, mass 10, acceleration is what is asked. So very simple. So 100 into zero point 0.5, so this will become 5 into 10, 50. 100 minus 50 to be 50. So 50 into 10, so A is equal to 5 meter per second square. Okay, absolutely nothing very difficult there. A block B is pushed momentarily along a horizontal surface with an initial velocity v. If mu is the coefficient of sliding friction between B and the surface, block B will come to rest after a time. So that means come to rest means final velocity is 0. So that means final velocity v is equal to 0. Initial velocity u is given as v after a time. So final velocity is 0. Initial velocity is given as v. Acceleration is what I do not know. Time is what is asked. So since mu is given, mu is the coefficient of sliding friction, I can say a friction which was acting this way, which means it is opposing the motion. So F friction is equal to mu into N, mu into mg, mu mg. But I know force is mass into acceleration. So that means m and m will cancel. So acceleration will become mu into g. So that means the retarding force, right? The force due to the friction will be in the opposite direction. So since it is in the opposite direction, you have to take a minus here. So I should take it as minus mu g. So that means T is equal to V by mu g. And so T by mu g, V by mu g. Yeah. So this must be the correct answer. Okay. Very often you will be using this concept mu is equal to mg, but don't forget on this side you have to put m into a, mass into acceleration. This acceleration represents the friction or retarding force, right? Retardation. Okay, this is where many of you will get a confusion. F is equal to ma means it is forward moving. Well, F is equal to ma is true for all the things, all the forces. So that means this is a retarding force. So that means acceleration is retarding acceleration or negative acceleration. If you have any doubts, please stop me. Otherwise, I'll keep on moving. Block of mass m is in contact with the cart. This is the mass and this is the cart. Shown the coefficient of static friction between the block and the cart is mu. The acceleration alpha of the cart that will prevent the block from falling satisfies. So that means what this means is it's kind of standing in the air, right? So obviously you would expect it to fall down because it is mass into gravity. But what if I said that, I'm sure we have seen these kind of situations many times in our day-to-day life. When you're going at a very high speed, something will be sticking, right? Even in a car, very often the many things might get stuck on the windshield. So that means the mg is still acting, but somebody is preventing it from falling down, and that is your F friction between this and this. So that means now the friction is this way. What, sir, in the previous problem you said it is this way. Well, here it was moving this way, so the friction is this way. But here, if you carefully see, the block is actually falling down, or it's about to fall down, which means the friction will be acting upwards. So friction will be mu into N. And here I should not put mu is equal to mg because N and mg are not equal. Okay, so that because the normal reaction will be normal to this surface, so that means normal will be acting this way. So this is where many of you will have confusion, right? So I would say, we talked about pseudo acceleration in the last class. So when the car is suddenly starting, the passengers will get pushed backwards, and that is what we call as pseudo acceleration. So that means when this is going this way, or when this is accelerating this way, the block will experience pseudo acceleration this way, which is pseudo acceleration is alpha. And as I told you, when you want force, it will be m into alpha. So always remember the concept. Okay, if you have any doubts, go back and study the pseudo acceleration which we talked about in the last class. Okay, so when the car is moving forward, I will get pushed backward. When the car suddenly comes to a stop, I will get pushed forward. So that means it's like due to inertia, we will keep on continue to do the same thing which we are used to do. That's all. So once you get this idea, this is a very easy problem. Before getting this idea, this is a very confusing problem. So that means I would say this has to be equal to this. Once you get this diagram, it's a very easy problem. When will this not fall down? Only when the friction is equal to this one or more than this one. So that means the friction has to be more than or equal to mu n. So mg, I can put mg here, mu into n. N has to be equal to m alpha. So that means the acceleration alpha will be g by mu. So very often you will get a confusion whether the greater than or less than symbol. For example, here the easy method is when the gravity is more, it will fall down. So that means the acceleration should be higher. So that means as this value increases, this value will also increase. If the gravity is less, then the alpha can be less, acceleration can be less. And let's talk about the friction. When the friction is high between this block and this cart, then the alpha can be, acceleration can be less. So that means this comes in the bottom. So when this is high, this will be low. So I think this makes sense to me. So I would say go with this one. See if you have any doubts. I'm just thinking whether this, if I'm making any mistakes here. So let me check one more time because your friction has to be greater than mg. Only then it will not fall down. So that means your friction should be greater than or equal to mg because mg is pulling it downwards. So the friction is mu into or mu m alpha. So m so alpha should be greater than or equal to g by mu. Yeah. So this is the correct one. I think I made a mistake here, but this choice I have taken it correctly. So according to this, we should have chosen this one, right? So this is wrong because I just substituted in place of F friction, I put mg, which is not correct. F friction, the upward force should be more than the downward force. Okay, so take it down. This is the correct method. So this choice is correct. Alpha should be greater than g by mu. Conveyor belt is moving at a constant speed of 2 meters per second. The box is gently dropped on it. So that means without much of a disturbance, we are placing the box. Coefficient of friction between them is now is equal to 0.5. 5. The distance that the box will move relative to the belt before coming to rest on it. Taking G is equal to just think about it, what method you can use. So as I pull the belt, right, as the belt is conveyor belt is moving forward, and I place this, the friction will try to keep it along with the belt. There is no acceleration. So F forward minus the friction. See, this is a constant speed, right? So constant velocity or constant speed. Constant speed. So acceleration is 0. There is no acceleration here. If there was an acceleration after sitting here, this will also experience a pseudo acceleration. But right now, because of the friction, there will be some frictional force acting this way. You may get a confusion, sir. Why are you putting the arrow this way? Because the belt is moving this way, and are we not supposed to put the arrow this way? That's what even I would have thought. But on second thought, I am thinking that, listen carefully, as the belt is moving this way, when I put this will try to slip backwards. When I say it is trying to slip backwards, the friction should be acting forward. So that means it is the relative motion that matters. So that means this is moving forward and this is slipping backwards. Block try to slip backwards. Which means F friction acts forward. So F friction is equal to, as usual, mu into N. So mu into mg. F friction there is no other force here, right? Mass into acceleration. So acceleration will be mass into acceleration. I can write it like this and I can cancel out. I can find A is equal to mu g. I think we got the same result in some other question. Right? You can do like that. I'm just thinking if there is easier way to explain this. So friction is accelerating forward for a minute. Into acceleration. Yeah, you can arrive at the same result like this also. I can say sigma f is equal to ma I can say the only force which is acting is a friction forward. There is nothing acting backwards. So m into a. So it's the same thing. So a friction will become mu into mg. So m into a. So cancels. So a is equal to mu g. Okay. So either way we'll get the same answer. So now after that it's easy. So I can say the time required to stop. So it's accelerating forward because of the friction force, and it will um, so v squared is equal to u squared plus 2as. So initially it is with respect to this belt, right? It is stationary. So I would say with respect to belt, it is moving 2 meters per second. But once it becomes coming to rest on it, so that means final velocity should be zero. So initially there is a relative motion between them, and then this will be mu g 2 times mu into g. Mu is 0.5 into 10. So 0.5 into 10. So it will be 5. So this will be 5. Yes, this is what they are asking. So this will become minus 4 divided by 10, which is 0.4. So that's your answer. Reason why you are getting minus is the place where I place it, right? When I put the block, because of this movement, it will slip behind a little bit. So that means it will come to a stop a little bit in the backward. Okay. Anything not clear, please go through it. This is slightly confusing. Any doubts? Can I move on? Definitely it requires a little bit of thinking, not an easy one. I'll give you 1 or 2 minutes, so please go through it and tell me if you have any doubts. Please ask your doubts. Confusion you may get is, sir, how did you get 2 here? And the answer is, we are talking about the block, and the block is actually moving backwards with respect to this. So the conveyor belt is moving forward, which means with respect to the belt, this is having a negative velocity, minus 2. So if I want, I can put minus 2 the whole square also. Again, I'll get the same thing. Okay. upper half of an inclined plane of inclination theta is perfectly smooth while the lower half is rough. Block starting from rest at the top of the plane will again come to rest at the bottom if the coefficient of friction between the block and the lower half of the plane is given by. So I think we have done something very similar to this. I think we did it as two different planes. Now they are just giving it as one inclined plane. Earlier we have done it. Go back and check. Earlier we have done two inclined planes. Now both the things are given in the same thing, same inclined plane. So that means this is the block here. So it comes with certain velocity and then there is friction here. They are saying it's coming to a stop here. Okay, so what is the mu value so that it will come to a perfect stop? So top half and starting from rest. So that means u is equal to 0. Let me take this as L. This is also L. Length is same. Let's take this as theta. So they didn't say anything about time. So I can use v square is equal to u square plus 2as, because listen carefully, the first part there is no friction, so mg will be acting here, mg cos theta will be acting here, and this will be mg sin theta. Normal reaction is this way, so there is no friction, so nothing acting in the backward. Here I will get the same exact thing, except the friction will also will be added. That means I told you many times, if you remove the mass, that is my acceleration component. So that means let me try using v squared to as. So at the end of this part, it will come to a certain speed. So that means that will be v. U is 0. So that means v squared is equal to 0 plus 2 acceleration is, I told you, g sin theta, into this length is L, this length from here to here. So that is the first part. The second part, for this from here to here, as I said, it's exactly the same thing, except you should add the friction in the backward direction. So mg will be acting this way, mg sin theta will be acting this way, sorry, mg cos theta will be acting this way, mg sin theta will be acting this way, F friction will be acting this way, normal reaction will be acting this way. So F friction is equal to mu into N. I told you 1,000 times, if you put mg here, everything will go wrong, because you see it's not mg, it is mg cos theta. This and this are equal. So that means mu inclined plane n is not equal to mg. So mu is equal to mg cos theta. So that means somebody is pulling this way with the mg sin theta, somebody is pulling this way with mu mg cos theta. So that means the resultant in this direction is mg sin theta minus mu mg cos theta. This you can call it as force downwards. So m, if I take it out commonly, g sine theta minus mu g cos theta. Why should I write it like this? Because I want to keep the mass separately. Why? Because that will give me the acceleration. So that means this is a acceleration. That's all. So after that, it's the same story. Once you get this idea, it's a, getting the idea is a difficult part. Once you get this idea, which comes out of practice, right? So after that, it's very easy. So v squared is equal to u squared plus 2as. The final velocity here is 0 at the bottom. U is this thing, 2g sine theta L. So that means u squared will be, this is the initial velocity. If it is not clear, let me explain it one more time, so please listen carefully. Initial velocity is 0, it's coming with the velocity v here, and then again it is coming to a velocity 0. So that means this is the final velocity for this part, and this is the initial velocity for this part. So that means whatever you got here as v should be substituted as u here. So in place of u, we have to put 2g sine theta L. So that means instead of u squared, it will be 2g sine theta L. Not a square because this is already a square. Plus 2 distances L. Yes, so A is this one, g sine theta. G sine theta mu g cos theta. That's all. So simplify this, we'll get the answer. Since the other side is 0, I can get rid of 2. I can get rid of g. Right? I can take the g commonly out, and when I bring it on the other side, it will become 0. 2 same thing, L same thing. So that means what is left is sine theta alone is left. So sine theta plus sine theta, it will become 2 sine theta. The other side it will become minus, will become plus, so mu cos theta. Sin theta by cos theta will become tan theta. So tan theta is equal to mu by 2. So let's see whether we have that option. So mu by 2 is equal to tan theta. So yeah, mu by 2 is equal to tan theta. Out of anxiety, you may make a mistake of choosing this, but this is tan theta is equal to mu by 2. So that means you have to choose the correct one. Okay, because it looks like this one may be the correct answer, but if you choose this, it's wrong. Very easy problems in my opinion, but if you don't know these methods, if you don't know these concepts, you will be thinking it is a very difficult problem. Okay. Again and again, I am telling you, either you have to practice the problem before the class or after the class. If you don't know the problem, then learn the problem and then practice the same problem after the class. Okay, try it out yourself. That is the only way you can score in NEET. Otherwise, you cannot score. Any doubts? Plank with the box on it at one end is gradually raised above the other end. So plank with the box on it at one end is gradually raised above the other end. As the angle of inclination is horizontal reaches 30 degree, the box starts to slip and slides 4 meter down plank in 4 seconds. The coefficient of static and kinetic friction between the box and the plank will be respectively. So very simple. It may look like a very complicated problem, but in my opinion, it's a very easy problem. Okay, all these things are there in the handbook, so please go and take a look at the handbook concepts. So what they're saying is 5 degree, 10 degree, 15 degree, 20 degree, I keep on increasing. It doesn't slide. And when I reach 30 degree, it starts sliding. So that means that is the static friction maximum, right? So after that, it will be kinetic friction. So again, the same story. So I'm not going to repeat. So they didn't say anything about at this point it is slipping down, right? So that means this is the friction is maximum. So after that only it will start slipping. So that means the friction is there. So at this point, friction. So listen carefully. At this particular point, just close to 30 degree, it just starts sliding down. So that means just about this point, I can say that this and this should be equal. Only after that, this becomes more and this is a constant value and this is increased more than this and then it starts sliding. So that means this has to be equal to this. Maximum static friction. So mg cancels. So mu is equal to tan theta, which is a standard formula which you could have directly done it. If I directly say that, probably you may not be able to grasp the idea. So that's why I had to show you the steps. So tan 30. So tan 30 is 1 by root 3. 1 by root 3 is 0. I don't know, 1 by 1.7 something, right? So 10 by 17, how much is that? 100 by 17, so 5 times 35. So I think we will get around 0.5 something. Okay, so I think only 0.5, maybe the second digit we have to calculate. So 0.58. Okay, maybe they rounded it off here. So 0.6, I have two answers, so that means I have to calculate the second part of the question, which is kinetic friction. So as I told you, this is just the starting point. So after that, it starts sliding down. So that means the friction will not be static, it will be dynamic or kinetic friction. The diagram is pretty much going to be the same. Only thing now, instead of static friction, right? Static friction, it is dynamic or kinetic friction. Slides 4 meters down the plank in 4 seconds. So G sine theta, like what we did in the previous problem. G sine theta or mg sine theta is acting this way. Mu mg cos theta is acting this way. So that means if I remove the m, this minus this will give me the acceleration. It's very similar to your previous problem. G sine theta minus mu g cos theta. So mu is what I want to calculate. Sine theta will be 30 degree. G is given as 10, or you can take it as 10. So they are given some additional information. It takes 4 meter sliding down in 4 seconds. So that means I know the acceleration, I know the time, I know the distance. So which formula comes to your mind? I think I can use S is equal to ut plus half at square. Right? Initial velocity is 0. Distance covered is 4 meters. Half acceleration is this entire thing. Time is 4 seconds. So that means 4 into or 4 square. So I can cancel this 4 and this 4. So I will have 1 on this side. So this 2 and this 4 will cancel to 2. So 2 will come on the other side. G is 10, so we can take the G commonly out. Sine 30 is sine 30 minus mu is what I want to find, mu kinetic, cos 30. So 10, this will come on this side, so 1 by 20. Sine 30 is 1 by 2 minus mu k, cos 30 is root 3 by 2. So I can cancel this 2 everywhere. So I want mu k kinetic. This is zero point 0.1. So zero point 0.1 comes on this side, it will become 1 minus zero point 0.1, 0.9. Okay, root 3 is equal to 1 minus 1 by 10, which is 0.1. Or you can write as 0.9 can be written as 9 by 10. Root 3 will come on this side, so it will become mu k on this side. Simplify this, I should get the answer here. So any easy method, I can do 3 into 3, 10 root 3. This is 1.7, so 3 into 1.7 divided by 10. So this will become 21, 2, so 5.1 divided by 10 is 0.51. So 0.5 is the answer for second part. So that means the static friction, so this is mu s static, this is kinetic. So from your theory knowledge, you should know that the maximum static friction is slightly higher than the kinetic friction. So this is your static, this is your kinetic. So that means you should know that, go back and check your handbook, okay, very important knowledge. So that means it agrees with my theory knowledge. So that means 0.6 is higher, 0.5 is smaller. This does not agree with it correctly. This is also wrong because this is smaller and this is higher. This is kind of okay, but the values are very far away. And this also does not agree. So any questions? Anybody not following anything? I'm telling you again and again, you should have some good knowledge. Okay, attending the classes are very important. If you simply depend upon the solution books, most of the time I have seen they don't even give you this, graph and these diagrams. And how can you imagine, what is going on here? If I give you only this part, there is no way you're going to understand what is, how they arrived at this one. So that's why I say attending the classes are very, very important. If you think you will study from YouTube videos and solution books, definitely it will not be possible. Okay, so it's left to you. You have to understand what is the importance of attending the classes. And many students, the moment you see this one, they think that it is very complicated, and that is not true, right? Many times it may look very complicated, but it might be a very simple problem. Okay, if you know the method and if you follow the steps, I'm sure you will arrive at the answer. Tension in the string is pulling it this way. F friction is acting this way. Mu into N. Since it is horizontal, I can use mu into mg because mg will be acting downwards, normal reaction will be acting upwards. Okay. Why this block is not falling down? Because somebody is holding it up, and that is what is your tension in the string. And who is pulling it down? M to G. So let's say it is sliding down with an acceleration A, which means this will also be sliding with an acceleration A. Okay, that's all. So two forces here, acceleration, two forces here, acceleration. So they're asking to find the tension in the string. Okay, so I'm sure we have done all these things in the handbook. You should be thorough with the handbook theories. So if you want, I can show you where it is. Yeah. So I've shown you many times, right? Lift problems means come here and study. Pulley problems means like this. Monkey problem, right? Person or a monkey climbing up. So all these things are standard standard methods. So if they ask you questions in this, you should be very comfortable. Like contact forces, right? If you did not study this in the 11th standard, at least now you should study it. Okay. And as I told you, sometime soon I am planning to get started with the 12th portions. Maybe I'll talk with Kesav sir, and maybe after this chapter we can get started with 12 portions because I really want you to feel comfortable so that you can align your school work and this work should be same. If I keep teaching you something else, I'm sure some of you may not be able to focus on both your school work and this work. Okay, quickly do this. I think it's very easy. So sigma f is equal to ma. So T minus M2G is equal to M2A. Sigma F is equal to MA. So T minus mu K mg is equal to, this is M1G, so it will be M1A. So this A and this A are same, this T and this T are same, that's all. So simplify this, we'll get the answer. This is what many students think it is very difficult, but it's a 10th standard elimination method. So I want T, so that means I have to eliminate A. So substitute. And one mistake I'm doing here is, anybody, what is the mistake? Acceleration is going downwards, so what should I put here? What is the mistake I've done? You should put a minus here, okay? So if you don't put a minus here, it will go wrong. That's all. So simplify this, we'll get the answer. So I can take A from this and put it over here. Either way you can do it. So substitute this over here, you'll get the answer. So T minus M2G is equal to minus M2. In place of A, I have to substitute this one. So T minus mu k m1 g divided by m1. I want t, so do the simplification, you get the answer. So m1 should come here. Minus into minus plus, so mu k bring the t on one side, so t m1 plus m2, bring this on this side, so it will be m1 plus m2 g is common, so what is not the same, it will be 1 plus, okay, so t will be nothing but this divided by m1 plus m2. So you see, after that, once you get the idea, it's all just simple mathematics. Okay, so this is what sometimes you folks think it is difficult, but it's actually very easy. Algebraic problems, not a numerical problem. So m1, m2 divided by m1 plus m2, 1 plus mu k is what I have to look for. 1 plus mu kg, yeah, so that's your correct answer. Everything looks almost same, so you have to be careful. Okay, so any doubts? Sandamil Chelvan, Sharmila, Bhumika,
No, sir.
no doubts. Okay. Sharmila, are you following everything? Bhumika, no answer. Bhumika, are you following? Okay, so I'm going to stop here. So continue with the problems. Okay, as I told you, either you have to do before the class or after the class. Work it out, study it. If you are serious about your NEET or JEE. Okay, thank you all. If you don't have any doubts, you are free to go.